Be learning about operation research, which is also called OR. I'll be putting the photo of the question here and you can look and read it. I'll be trying to explain you how to solve it. So the main briefs, I'll be starting out with the first question, raw materials A and B given and the tons of material being given. And we have to first know the profits also. That is, we have to make the equation first for the raw material non-negative constraints as well as the marketing restrictions. After you find the equations, you have to make sure you solve it from equating it to 0 and then finding the equation, solving it with graphical representation, and then we have to optimum solution for the same thing. Now after you find the region of feasibility, it depends on greater than equal to. If it is the equation has greater than equal to, then that means the lines go outward. Less than or equal to comes towards the origin. Now second question talks about two products which have been made out of 3 machines. So the table shows 10, 6, 8, 5, 20, 15 and the profits are 2 and 3. You have to take vertically, that is 10x plus 5y and 6x plus 20y, 8x plus 15y, and profit is given here, that is z. It's all less than or equal to, and why it's 600 is because 10 hours per day, and we know we have 1 hour consists of 60 minutes and 10 hours consist of 600 minutes. The graph also is been mentioned here. You have to solve both with graphical and optimum solution. Third question is also the same. I'll just show you what is the difference up here. We see only the differences in the profit and also the sum values. All are same. The next question, I'll show the graph. In fourth question, we see bottles which are being manufactured. In this question, there is some error. We have 1 hour which has been spent for making 1000 bottles, but here it shows 3 hours for A, and it's something messed up with this question. So I'll just show you the answer. Fifth question is talking about the brands, which are 2 brands of cards which have been made and the different things. This is also almost same. The first question, how we have to solve, the same relates. Sixth question also is having same thing. Seventh question, but the only difference is the graph has outward, because here it is showing minimum request. So if it's cheapest or minimum cost, that time the graph will have outward, mean like this. Lines will be outward, feasible region will be outward. So there is no bound. Seventh question, FAO, also is having the same thing. Eighth question, this is little tricky. We have the table that is washing machine and dryers. First we need to make sure we equate both, that is 10,000, 10,000, that is x and y, x plus y less than 10,000. Next one, 16,000, 7,000 for the motors. You have to equate it and then we have to get the value and then make the equations. The rest of the things are same. When there is value like x is less than or equal to 9,000, then you have to put the value that is vertically 9,000, that is x 9,000, so vertical, y 7,000 or 5,000, that is vertical, then horizontal line will come. Ninth question is why the value of A, that is A product type of belt, is twice that of B, and then make an equation of it. It's almost same. And last question, 10th question, 60%, that is x is less 0.6 times of total x plus y. Then we get the equation, that is marketing restriction, raw materials, and then profit is also being given. It's the same. 11th question, here also it's the same like was it in 9th question. It is 100 minutes. Here 8 ounce of bottle and 16 ounce of bottle has been given, two different capacities. Then we have to first equate them, make an equation, and then use the same approach, graphical approach. The graphs will be shown. 12th question, we have sweepers and polishers. We have to make sure that in the end we have to add 5 more runs, is 5 more hours. Each hours costs 50 rupees, so 250 rupees extra. You have to reduce and check the profits, whether it's beneficial or is it just waste of money. It's the same. 13th question, it's also a tricky one. When an old hen and an young hen is being taken, and the amount which is being spent for feeding it and the profit which is being got is being calculated first. After you calculate, that is a profit which is being made. First I'll be telling the old one is 20 rupees, 50 rupees is the young one, 3 eggs per week, 5 eggs per week, 1.5 rupees for each, and the old one gives cost is 5 rupees for feeding it. So 30 rupees profit should be there per week, and 800 to be spent on the hens. So first we need to find the profit, that is cost of each egg, that is 3 eggs per week for the old, that is 3 into 1.5 minus the feed, how much it feeds, 5 rupees. So we have to assume for the young one is also 5 rupees, and then check the profit equation. After that we have to make the equation for each hen, and then we have to find the maximum output. Yeah, the graph will be shown here. The 14th question, here also we have different contents of alloy, and then we have to make sure all the things are matched and maximum amount of profit is being got. It's similar type of question, but here it's just cheapest way, that means it is going to go outside. Last question, in this there is no bounding region, the solution is unbound.